No worries. Oh, hello everybody. Thank you for our second part of this session. First of all, thanks to Brad for doing an amazing presentation. And he's also an amazing manager. Maybe give him a round of applause. Thank you, Brad. So in the second part, Brad kind of gave you an introduction to AngularJS. And what I want to talk about is how does it all work? But specifically, not just how it all works, but what are the reasoning behind it? How do we get to where we are, and what are the goals we're trying to solve? So let's get started. The first thing what you do when you want to build a framework is you say, well, I want to do data binding. And the goal is that you really want to separate the code from HTML, right? You want to be able to implement your application, your behavior, and you want to have web designers somewhere else implement the UI. And you don't want to get in a situation that every time the web designers change something or the code change the implementation, you have to go through the process of reconciliation of the two parts. And this is where data binding really comes in. And the goal, as I said, is really to separate code from the HTML. Now, what does it mean to have data binding? It really means that you have some model, right? In this case, we're going to represent it by this chip over here. And the model needs to drive the DOM. And DOM is both, when we say drive the DOM, we mean both structurally, which means we adding and removing things from the DOM, but also attribute-wise, as in we're adding and changing things like text, CSS properties, and so on. So both structural and attribute changes is what we're driving over here. And notice the arrow points from model is the source of the truth, and it drives the DOM. But there is this other thing, which is that we don't actually want the model to be aware about the DOM. We actually want the dependency to go the other way around. We want the DOM to be aware of the model, but model should be blissfully unaware of this. And the requirements for this is really because really any kind of an object can be a model. And in many frameworks, when you try to use them, they make you inherit their superclasses, they make you follow any kind of conventions, or maybe you have to have getters and setter methods, and that really limits the kind of objects which become available for model. And I think one of the reasons that Angular is so popular is because we really looked at this and said, no, we really want to be able to take any kind of object, and anything should be able to be a model. So the requirements for data binding is model is a plain old JavaScript object. Right? This is the good old Pojo from the Java world, but we're just calling it JavaScript. Meaning that anything can be a model. Because anything can be a model, and because the model itself does not inherit from anything, there's no framework dependency that we force you to insert into the model, we now need to have a way of detecting value changes. And this is a tricky part, which at first might look as unsolvable, and so there's some crazy ideas we have about how we can solve this particular thing. But this is basically what allows you to take a regular Pojo and be able to see the changes to it. The next thing is, once you have that, you need to be able to easily describe the value in a model. What I mean by that is, models are usually hierarchical, the complex objects. They're not just simple hash maps. And so you need to be able to traverse a complex property, like go to user.addresses, because user can have multiple addresses, take the fifth one, and look at the email, right? So there's a complicated path by which a model needs to be traversed. And for this, we need some kind of an expression evaluator. And we'll talk about it later on. And the last piece is that just like we want to encapsulate behavior of code, we also want to encapsulate DOM. And this is where the idea of directives comes in. So we start with plain old JavaScript objects that represent the model, and we are going to look at all the pieces all the way up to the DOM. So because model is blissfully unaware of the world around itself, right? That's kind of one of the core tenets of this particular thing. We need a way to keep track of these dependencies. And this is what scope actually is responsible for. The idea of a scope is that there is a JavaScript object that represents the model, which is blissfully unaware about the world around it. But somehow we have to add dependencies to it. Somehow we have to add behavior and things so that we can observe its changes and update the DOM accordingly. And so the purpose of the goal of this is to really, the goal of scope is to basically do this particular job. Now, how might this look like? So let's say we have a user. user is a class. This is how you declare classes or types in JavaScript. And we might have properties on it like full name and username. And one of the things we would like to do is data bind to it. As you can see on the bottom, user.fullname and user.username in double curlies. And the way we can achieve this is by instantiating the scope and assigning the user into the scope. Now notice in this particular example, this is not real Angular code, this is kind of the pseudocode, how it works internally, is we're saying, well, scope in this case is really just a object. And so it really acts as a hash map. And just by assigning things to it, we can start data binding to it. And so if we can figure out a way to detect changes, then we can basically do the data binding. And this is the whole trick of Angular. How do you do this? How do you achieve this particular data binding? Now, the next thing you have to solve is that if you have a template, in this case, we have an example of using a name, it turns out that the context of what name is can actually change depending on where the name is declared. So at the top level, the name that's all the way at the top might not necessarily be the same exact name as the one that's inside of the ng-repeat. As a matter of fact, in this particular case, because of how ng-repeat works, the two are very different. And so you now have to have a set of rules or some kind of strategies in order to figure out, well, how do I make multiple copies? How do I allow the same expression to refer to different things inside of a system? Specifically in the case of ng-repeat, as you unroll the loop and you have multiple copies, each row inside of the loop really has to point to something else. And this is again where scopes comes in, is because what's inside of double curlies is a path starting at the scope. And by having multiple start locations, which is basically multiple scopes, we can achieve the right behavior. But there's a complication. Because we have different starting locations from different places, we don't know whether a particular property is actually defined on a child scope or a parent scope. And so we have to somehow resolve a way of saying, well, just because ng-repeat doesn't declare a particular property and we still want to bind to it, it doesn't mean that all of a sudden all the bindings become null and void. We should somehow magically just inherit from parent ones. And this is where the concept of inheritance comes in. So when you have a scope, let's say you have a parent scope, you should also be able to provide child scopes. And child scopes have these interesting properties. So first of all, when I do parent.name and I read it from the child, notice I'm writing the parent into writing the name property into the parent, but I'm reading it from the child. And in this case, the child can see everything that the parent can sees. But if I go ahead and I override the property inside of the child, when I read it back, notice we can read the same value out that we wrote into it, but we don't actually destroy the parent one. So the reads and writes are actually coming from different locations. This is what Brad alluded to was as global reads and local writes. This is the kind of properties we want our scopes to have. Now, how can we achieve this? How does this inherent method actually works? Well, it turns out JavaScript has something called prototypical inheritance, and prototypical inheritance is exactly what we're looking for in this particular behavior. So the way you can implement an inherit method in JavaScript is that you can say, well, I have a particular thing called a parent, and through a bunch of trickery, which is basically you're creating a new function C, and you're going to use it as a type, so really you're creating a new type C, you can set the C's prototype to the parent object. And then by instantiating C, what you're actually creating is the last line, which you can see, as you can see, child dot underscore underscore proto underscore underscore is actually a parent. And this is how JavaScript resolves inheritance. So if you have, for example, let's look at the classical object-oriented world. When you have methods on an object, the methods really are not instances of that object. The methods are actually shared across all of the instances, right? So the methods actually are on a kind of a type level. And they're not type level in terms of static, but they're shared across all the instances of this particular type. Whereas the children, which is the actual instances of a particular type, the properties, the fields on that object are on a specific instance itself. But when you're using an object, you don't have to figure out, well, do I really want the method or the field? Because of prototypical inheritance, the two get squashed and you can read from a common namespace. And so we're exploiting this particular behavior of JavaScript for our benefit for the scopes. And we are creating child scopes that will have the same exact properties. So the way it actually gets assembled visually is that you have an outer scope that will be used to resolve the top level name. So if somebody at this top level, what we're really saying is look at the property of the parent scope and use that. And inside of the green box, we also have double curly name, and so that one actually resolves against the individual rows inside of a scope. So if the repeater unrolls 3 times, there's 3 copies of it. And depending on not whether the repeater overrides the property, the field name comes either from the overridden one or from the parent common one from the top. Okay, so now that we've described how we can get the behavior of scopes, the next thing we have to solve is how do we notify the system of property changes, right? Because without some kind of a notification system, we don't have data binding system. So to be able to data bind and have this property where a model, the change in the model automatically reflects to the UI really implies that we have some way of detecting this change. And we have this added complexity of saying, well, the model itself cannot have special methods or behaviors, and therefore we don't have the model really isn't actively contributing or is not actively cooperating with us to get these information out. And so we have to kind of figure out in retrospect, okay, well, what has changed? So how does all this thing work? So first we provide some API. We basically say if you make a double curly name, what you're really saying is you're telling the system, look scope, there's some property name, watch yourself for this particular property change, and if the property changes, go call what we call a reaction function. And in this case, reaction function is very simple. It simply says take the element and assign the value into a text. And this is essentially what data binding is. So if you imagine if you have a span element, and span element has either a double curly on it or ng-bind, behind the scenes, what really happens is we just say scope, watch the expression. In this case, it would just be name. And as the expression changes, we simply take the span element and we assign new text value in it. And that creates the effect of having data binding in there. So that specifies what the APIs are, but it doesn't actually tell us how it works. So how can you do non-intrusive change detection? Now, it turns out that JavaScript doesn't have anything available to us. Now, some browsers allow us to write different kind of getters and setter methods, but it's not consistent across all browsers. And furthermore, it kind of invalidates the idea of having POJOs, because imagine you have a third-party library. Suppose you could use proxies. Let's talk for a second. Many browsers have proxy objects, and proxy objects can intercept reads and writes to an object. But basically what you have is you have a real object, and then the real object is wrapped inside of a proxy. So as long as you're accessing it through the proxy can do all the interception. But if somebody forgets to access the object through the proxy and instead goes directly to the object itself, all bets are off and data binding doesn't work. Now, this is a problem because if you have a third-party library, for example, a library that returns XHR or data from the server, the library most likely will retain the original copy of the object. And after the fact, you will take the object and you will wrap it inside of your proxy. But what if the library goes back and changes that reference that it has retained? You'll never know about it. And so proxies or these getters and setter methods, while they can work if everybody is consistent and everybody follows the same set of rules, they'll never give you the seamless idea of being able to just take any object anywhere in a system from any third-party library and be able to data bind to it. So the simplest way to do this is to do dirty checking. And what dirty checking basically does, as you can see in this method over here, is you simply say, remember the last value. Whenever somebody calls dirty checks, I'm simply going to look up the new value of the system, compare it to the last value. If the values are not the same, I will call the reaction function, and I will remember the new value for the next iteration. So this is basically how change detection happens in Angular. The tricky part is figuring out when to call dirty check. Now, there seems to be this persistent myth out there that we simply have a set timeout every few milliseconds that runs this, but that would be an excellent way to run your battery to the ground. So there's actually a more clever way to do this. We'll talk about it in a second. But fundamentally, this is what happens. Now, the next question is, well, is this slow? How long does it take to do dirty checks? Well, it turns out that for a modern CPU to compare several thousand objects under a millisecond is not a problem. Really, or looping over 1,000 things is not really a problem, provided that we can quickly resolve the expression. So provided that we can quickly look up the name property. In this case, it's just scope.name, which is just a regular property lookup. Provided we can do this quickly, all the other stuff is really trivial for a modern CPU. Now, there's a second problem to this particular thing with dirty watching, which is that imagine you have two watches that have a dependencies, where the first one simply says, look at the property count. If it changes, go and print alert. The second one says, look at the property name. If it changes, go and increment the count. But notice the order of registration. The count happens after the watch for the count. And so if you execute this from top to bottom, or if you dirty check this from top to bottom, what happens is you will miss the fact that count has changed. You'll look at the value of count and say, did it change? And the answer is no. You're going to look at the value of name, and did it change? And the answer is yes. So you will execute the reaction function, and you will increment the count. But there's no way for you to know that you've incremented the count. And so now you essentially have gone out of sync. How can this manifest itself in the UI? Well, that's relatively easy. Imagine you have a button that controls visibility of something, but the visibility it controls is above it, right? So from a DOM structural point of view, the thing that we're modifying is lower than the thing that is being modified. The dependency is reversed. And so this creates a problem. And the way to solve this particular problem is that we have to run the dirty check not once, but multiple times. So the question is, how many times do you have to run it? And the answer is you keep running it until you manage to go through all of the watches and detect no changes. Now, obviously, you could get into an infinite loop. So you have to make sure that at some point you stop. And a good rule of thumb that we have inside of our system is, I believe 10 iterations. So after 10 iterations, if their model does not stabilize, it just means that you most likely will never stabilize, and then we just throw an exception and we quit. The other thing to notice about this particular system is that it's asynchronous. And at first it might look like a deficiency, but actually asynchronicity is a good thing because it automatically gives us coalescence. So if, for example, there's a loop that tries to insert rows into an array, and we data bind the size of the array, we really don't need to update the DOM every single time somebody inserts the item. We really just want to see the full final number of items that inserted at the end. So the coalescence is something that comes for free out of this particular system. So we described how we have a scope, we described how we have a model, how we can read the model, how we can check to see if the model has changed. Really, the last piece of puzzle is figuring out how do we know when to check. And it turns out that there's really only, the only time you have to check is, or rather, let's back up a second. The only time something could have changed in the browser is if JavaScript engine has run. And JavaScript engine doesn't run continuously. It runs as a response to an event. That means that the only time something could have changed in the system is if the server came back with a response, so we have an XHR response, a timer has fired, or user has interacted with the UI, for example, dragging the mouse, clicking, or something like that. But even that is actually a much larger set than what you actually need, because you know whether or not you have fired a XHR to the server. Therefore, not every XHR that comes back necessarily requires you to go and do dirty checking. You also might know that whether or not somebody has used ng-click or ng-mouse move. And so if nobody has used ng-mouse move or ng-click, there's really no need to listen for those click events and try to do dirty checking over there as well. So by carefully looking at the kinds of directives that are used within the application, we can actually narrow down the list of events that we should care about, which could potentially lead to change in the model. So the way to think about it is, the way browsers work is you have a native code, which is your C code, and you have your JavaScript, which is your VM, right? And the native code keeps track of something called an event queue, which is all the things, all the jobs that have to be done by the VM at some point. And when events happen in the system, rather, when XHR comes in, when set timeout gets scheduled, when the user clicks on things, all of these items, all of these events get inserted into the event queue, and they get sorted by time. So if you say set timeout 10, and then you say set timeout 20, the 10 goes before 20. When the time comes, the native implementation calls into the VM with this particular thing. Now, it would be ideal if we could somehow automatically just run the dirty checking on the end of the VM, but there's no such API, and so therefore we have to detect this particular condition. And the way we detect this particular condition is just like native code has an event queue and calls into a VM. What we set up inside of a JavaScript is kind of almost like a VM inside of a VM. What we're saying is, inside of the JavaScript world, there's really two worlds. There's the JavaScript native world, which works just like you would expect, and within it, there's a subset, which is the Angular world. And the way you can tell in which side you happen to be is you can look at the stack trace. And if somewhere above you there is a call into $apply, that's the gateway that allows you to go into Angular world, then you know you're inside of the Angular world. What the Angular world really means is that when you're inside of the $apply, there's really just a try finally statement in the $apply that says, on the end, right before I exit this particular stack frame, I want you to run the dirty checking. And so on the end of the apply cycle, the system runs dirty checking. This is why when you use our XHR method that's provided, which is the $HTTP service, we automatically wrap the response in $apply, so you don't have to, and it just works automatically. But if, for example, you use WebSockets, we're not aware of WebSockets, and therefore the data binding will not work out of the box. What you have to do is that every time an event comes from a WebSocket, you have to wrap the callback function inside of a $apply. And that basically just transitions you into Angular world. So when the callback gets processed, the $apply can then go and do dirty checking. Now, notice inside of here we have actually two loops. We have something called an eval async queue, and we have a watch list. We'll get into eval async queue in a second. Watch list is simply a loop that goes through every single registered watch and dirty checks it. And it's a loop because, as I said earlier, we have to run this thing many times over until we know for sure that it stabilizes. So typically, we run this 2 times. Once to process the particular changes in the system, and the second time to actually verify that there are no backward dependencies in the system. There is another thing called an eval async queue, but we'll talk about that in a second. Okay, let's talk about the eval async queue. Imagine you have an API called the cache API. What this does is it returns a value from a cache. Now, there could be a cache hit, in which case it's easy. We can just simply return the answer that we want. Or there could be a cache miss, in which case it's more complicated because we have to talk to a server and do an XHR. But the moment we're talking to a server, we automatically become an asynchronous API. When, on the other hand, we already have a cache hit, we can resolve and do the callback synchronously. As a matter of fact, synchronously is really easy to do, and asynchronously becomes tricky and difficult. But we have a problem. If you implement the code like you see above here, synchronous version of this code will not work, whereas the asynchronous version of this code will work. And the reason for that is because the assignment, the return value of the cache API, gets assigned to a local variable called result1. That variable might not be visible inside of the callback if it's synchronous, but it is visible when it's asynchronous. Now, this kind of issues are really hard to track by because oftentimes at the beginning on the side of your testing, caches are always empty. Therefore, they're always called, these API is always asynchronous, and as the application runs for a while, these APIs slowly transition from being asynchronous to synchronous, and this is just nightmare, bugs waiting to happen, weird conditions that are hard to replicate, and so on. So it turns out there's just a good idea to keep this in mind, and to simply say, look, if an API is going to be synchronous, it should be synchronous all the time. And if the API is going to be asynchronous, it needs to be asynchronous all the time. And so really the proper way to do this is that if you have a cache hit, instead of calling the callback immediately, you really want to say is call it in a little bit. Now, how do you basically say call it in a little bit inside of JavaScript? Well, you do set timeout 0. But set timeout 0 is very problematic for us for a couple of reasons. Mainly that in this previous diagram over here, set timeout 0 means that we exit the JavaScript world and we go back into the native code. But notice before we go back to the event queue, we insert this box that's called event renderer. DOM renderer. And what that does is it will do a reflow of your DOM and it will try to repaint any rectangles that are necessary. The trouble is that we might have been in the middle of trying to render something to the user. So what the user will see is a form that is empty, and then immediately after that, the set timeout 0 will fire, which will then give back the asynchronous cache hit to the user, and now we're going to repaint again with the actual values. And this user sees as a flicker, right? You see no data, and then immediately after that you see data. Not only is the user sees flicker, it's actually very wasteful because we have gone through painting twice. If we could just coalesce the two operations together, we wouldn't have to do this. But we can't coalesce them because the asynchronicity is the problem. But if you think about it, what does it mean to be really asynchronous? Nothing is truly asynchronous or synchronous. It's always something with respect to something else. So everything that happens in the browser is really synchronous within the main method of the browser, right? Once the browser is launched, everything in there kind of happens one after the other. But with respect to any particular point in time, like for example, any particular invocation of VM, things are asynchronous in the sense that the VM exits and some point later in time, the VM re-enters. So the question of what is or isn't asynchronous is really a question of with respect to what. And the key in this particular case, in this particular example right here, is that we cannot be synchronous with respect to the frame where the method got invoked. So if you go back to here, the issue is at frame number 2, we're calling the async API, and then from frame number 3, it will attempt to call frame number 2 again, and this getting back is what causes the problem. So what we really have to do is we have to drain frame number 2 before we come back to the callback in there again. And the way we can do this is because the apply that actually wraps the whole of the whole of Angular world has that second loop, which we have shown you up over here, which is called the eval async loop. And this is what allows us to process a synchronous mode in a synchronous fashion. So the idea is that inside of the cache API, when we have a cache hit, we say, please process this asynchronously. This gets queued up. Just like in here, you would do set timeout 0 and you would queue it up inside of the event queue. The same exact thing happens, but all inside of the AngularJS. And therefore, we can completely bypass the re-rendering of the system, and we can render the page without having flicker. So expressions. Expressions is the last missing piece of the puzzle. And the key over here is really you want to have code of least surprise. And so when I say something like user.firstname, it turns out that usually the user comes from the server, which means at the beginning you don't actually have a user. User is undefined. And so when you try to execute user.firstname, you'll actually get a null pointer exception. And the closest thing we can come with JavaScript to it is that you really want to say something like eval with scope, return, and then the expression user.firstname, right? But there's a couple of problems with it. As I said, if the user is undefined, this is going to throw an exception, and exceptions are very expensive in any language. The second problem is this with scope doesn't quite work the way you think it does, mainly because any writes will end up inside of the window, not inside of the scope. And so with scope is actually a feature that's mostly not exactly what you want. A lot of people are saying that it really shouldn't be inside of JavaScript. I'm not going to go as far as banish it from the language, but it is problematic and that these use cases are very limited. The second problem is we actually are using eval in this particular case. And eval makes it, a lot of security people have concerns about eval, and more importantly, there are modes in the browser where evals are not allowed, like CSP, the secure mode of the browser. And so what we really need to do is we need to generate a piece of code that says if scope has a user, and only then can we actually dereference it. So expressions look like they're JavaScript, but they're not, because they have to deal with this issue of being able to dereference things that are undefined, but also we can't just evaluate them as expressions in JavaScript because one, eval is the wrong way to do it, but also because we don't actually have a good mechanism for doing this, and with scope is actually not that good for us for this particular use case. So eval cannot be the solution, and we kind of already covered all these reasons. So let's think about the box. What can we actually do to pull this off? And so, I remember a few years ago when I was working on this particular problem, I was trying to get this done. One night I just got frustrated and I said to myself, this is just crazy. I just can't get the semantics that I want. Forget it. I'm just going to write my own lexer parser and really just implement JavaScript in JavaScript. And it sounds a little crazy, but it turns out that was kind of one of the best decisions we've made, because it really gave us the freedom to have any kind of semantics that we want. And I don't know, of any other framework that actually allows you to have this power to do these kinds of tricks. And really, by having your own lexer and parser, you do have a full control about the syntax and the semantics of how things get executed. Not only how, when, and so on. And so it is kind of a out-of-the-box kind of thinking that I think is very cool. So the last piece of the puzzle is we want to express our intent in HTML. So when you have something like ULLI, you put ng-repeat in here, it's very easy to read because it's declarative, right? When you have code, you want to read and understand what the code does. The way we do this is really, we kind of pretend in our head like we're CPU, and we kind of go through the loops and we kind of unroll it and say, oh, I see, this thing does this, and then we kind of flow through the system. And it turns out to be able to do this takes years of practice and training, etc. And most people just can't do this unless they have this training. And so you can't, and this is called the imperative code, and you can't take imperative code and show it to non-programmers like web designers. Most of them have troubles with this. But declarative code is actually easy to grok because it's descriptive, and you can go to anybody who doesn't even have any formal training in programming, and you can say, look, a repeater will simply make multiple copies of this. Center will center something. Class will apply red color to something. And you can mix and match those. And most people have no troubles reasoning at this level. And so what directives allow us to do is to express our intent, or rather package up all of this programming code, all this programming behavior into declarative packages that we can then share with outside users. Now, it's not just sharing with outside users that's important, but it turns out that it's just easier to reason about this thing. So declarative code is simply easier to reason. Even if you already know how to read imperative code and understand it, declarative is simply just easier to reason about. And so what we want to do is we want to express intent. And so in this case, there's an ng-repeater. It says user and users. And what this really means is the ng-repeat needs to make multiple copies. There's a second directive, which is double-color the username. And that simply just means watch the username, and any changes will get written in this particular location. So the way we package up these intents is an example like we see over here with the double curly, which simply says, scope, watch the expression, provide the reaction function, which in this case simply updates the text. This is what ng-bind does below. Now you can imagine something very similar for ng-repeat. It's a little more complicated and it doesn't fit on a slide, that's why I have not put it here. But really what you're doing there is you're simply watching the array, and if the array changes, you simply make a copy of this particular row and insert it in the right location. So the amount of code is a little more, but fundamentally, it's really the same exact thing. You're watching for the model changes. If the model changes, if the model has changed, in this case, if the items inside of the repeater change, you can insert and remove the appropriate DOM element to match the UI. So directives really allow us to take imperative notions and just package them up in nice, reusable, declarative things. And you can really turn your HTML into almost a DSL, right? A domain-specific language just for your thing. So you can have things like tabs and panes and so on. And I remember at one point somebody came to us and they were saying we were building some energy website where we have windmills, and so they actually had vocabulary inside of their HTML that had windmills, that had size and speed of the windmills, and it would actually render a windmill of different size and speed. I believe the amount of how far the project got along, the windmill got bigger or turned faster or something like that. So this is the kind of goal that we wanted with the directives, is that we really wanted to turn it into a declarative form, which is really easier to grok and understand. Okay, so you have these directives, and the question becomes, okay, well, how do I teach the browser new tricks? Like, I understand the concept of a directive, that you can go and apply this particular behavior, but browsers don't understand directives. They don't understand ng repeat. You know, how do we teach browsers these new tricks? And this is where the compiler comes into play. So what the compiler does is it traverses the DOM in normal depth first traversal. So we start at the root, and we visit every single DOM node. And we look for the attributes that we know of that exist in the system, which we call directives. So in this case, we're going to look for ng controller, ng repeat, the double curlies, and so on. And as we are walking the DOM and we're locating these things, we are writing for ourselves information about how to get back to it faster the second time. Turns out that doing any kind of any time that a VM, the JavaScript VM, has to talk to the native C code, that transition from the VM to the C code is actually very expensive. And so you want to minimize the number of times you have to cross the boundary. And because DOM is implemented in C, every time you access any property on a DOM element, you're actually crossing that boundary. And so you want to minimize the number of times you do this. So the point of the compiler is to really just go through the DOM, find the directives, and make a kind of an index, a cheat sheet, what you might say, of all the things that we have, where they are, what properties they have, and so on. And what the compiler does is it packages up the cheat sheet along with the DOM, and we call this together a template. And what that template allows us to do is it makes it really easy for us to stamp out new copies. So when I say I need a new copy of this particular template, it's easy to do because all you have to do is you have to take the root node, clone it, and then you have this cheat sheet of all the directives that already exist in the system. And so all you have to do is apply those directives to the new stamped out, cloned template. So if you're a repeater, you can see how this would work. You simply grab yourself as the starting element of the compilation process, and you say, okay, pull myself out, turn this into a template, so let the compiler collect all of the children, attributes, nodes, and so on. And then when the repeater decides I need a new copy of myself because the model has changed, all we have to do is take a template and say, make me a new instance of yourself. And this is a really fast operation. This is what DOM allows us to do, the compiler allows us to do. So there are certain implications about this, in which, as you can see, you can't add attributes after the fact, or rather directives after the fact. Once the application is compiled, all of these markup really become meaningless. But it turns out that because Angular really discourages DOM manipulation, instead encourages you to do everything through directives, nobody should be doing DOM manipulation to add and remove rows or columns or rather attributes from elements. And so the fact that we cannot notice that things got added or removed after the fact is actually not a problem. But it turns out in the future we might actually change that, because there exists something called DOM mutation observers that would allow us to notice these particular things. And I believe we have a talk later on about the future of Angular and how we're planning on taking on all of the web standards that are coming up. Okay, So we kind of talked about how data binding works and all this stuff. Now let's look at dependency injection. So the point of the dependency injection is to get rid of setup code. And just like HTML became a declarative way of expressing your intent, with dependency injection, what dependency injection allows you to do is you can declaratively describe your dependencies. You declaratively can say, this is what I need to get my job done. So now imagine you have an application. The application has a house and a door. To instantiate this, you simply say new app, new house, new door. Now, how do we know to write this particular line? Well, it's easy for humans to do, right? Because we can reason and we can look at the parameters of the constructor methods. And we can see, oh, application needs a house. So we're probably going to have to say new house. But then house needs a door, so we're probably going to have to new door, and so on. We keep doing this until we build all the objects, and this is really what we can write. We can say new app, new house, new door. And just as we humans can kind of reason about this, it turns out there's only very few heuristics we can apply to this that we can actually make computer to reason about, and computer can generate that line for us, and that's the kind of the point of the eye. Now, why is this important? It's important because down the line, when you have a real application, we're not talking about 3 objects, right? We're talking about hundreds of objects or hundreds of types that need to be assembled in the right way. The thing is, down the line, we often decide to do refactorings. We say, well, we thought that this guy was supposed to be over here, the door was supposed to be here on a house, but really the door needs to be over there, so we need to move it. And moving it is difficult when we have actually written a real code like new app, new house, new door, because now we have to go back to this code and we have to rearrange things. But if this particular code is generated automatically, then we can just let the system automatically rearrange these instantiation processes. So how do we know what to inject? Well, we need to give hints to the system, to the dependency injection, what's known as a container. And so the way we came up to do this in AngularJS is we said, well, we'll just put a property on a function called $inject. And we simply annotate what it is that we're trying to inject. So as you can see, house says, well, I need a door, and application says, I need a house. And then you can imagine how this could automatically work. But when you're trying to write a test, unfortunately, you'll have this horrible side effect, which is you're trying to write a test like it should do something. What you really want to say is you want to inject a root scope into this method. But now it's a property that you have to put on a function, and so you can't just have a free-floating function. You have to pull it out, and you have to put the property on it, and how it has to have a name, and it becomes ugly, right? And like very quickly, you realize, yeah, these annotations are not really that good when you're trying to write tests, and we're big fans of testing. So how do you solve this particular problem? Well, it turns out that in JavaScript you can say house.toString, and that's going to actually return to you the original function. And then if you run it through some crazy regex expression, you can actually extract the original parameter names to the system. So in here, what was this? I'm sorry, I got lost. Oh, this goes forward, this goes backwards. There we go. So in here, we can actually look at the parameter name that the application needs a house. And based on that, we can infer, oh, right, I need to go get a house. So if you look at the way we're annotating these things, the names that go into $inject are exactly the same names as our parameter names. The two usually match one-to-one. And so this is the reason why we can simply run a regex on the object to string and have the actual injections automatically generated for it. Now, obviously, this doesn't work when you run code through minification, but tests don't go through minifications, right? So it doesn't matter. For production code, you'll use either $inject or we have another form of this. But we wanted to make sure that tests are easy to write. So how do you actually run this piece of code that automatically assembles your application? And turns out that's a very simple piece of code to do. And it's right here. So let's back up a second. If you have function door, function house, you can build an injector, that's the container. And you can simply say injector.instantiate house. And the system here can simply say, oh, right, house needs a door, so I have to do a new door, and then all the pieces get put together, and our house gets assembled. So how does this instantiate method works? It's amazingly simple. This is pseudocode. This is not the actual method. But the pseudocode, I think, draws a very important point, which is you say instantiate a particular type. You go on to the type's inject property. It's going to be an array, so you can apply a map. What map means is simply take attributes of the, take individual elements of the array and apply some function to it. And whatever the function returns, that becomes the new item inside of the new array that you return out of map. So type inject map instantiate simply says, take every single item inside of this particular array and convert it into instances of an array of instances of the same type that you're asking for. And notice the method is actually instantiated. It's self-recursive. And then once we create a list of arguments for you, we can simply say new type and then pass the arguments into, and voila, you have your objects instantiated. So this is really the core of dependency injection. It's an amazingly simple function. Now, obviously, there's few more things. You have to add caching, modules, some syntactic sugar. But if you add all these pieces, you have yourself a full dependency injection. Okay, so now let's talk about routing. One of the things that we wanted to preserve is if you're familiar with the old web, which is the round-trip application, that has this wonderful property that as you navigate within your application, the URL changes. And what that means is a couple of things. First of all, you can hit F5 to refresh the page, and you will be exactly where you left off. It also means that you can take that URL and email it to somebody, and they can open it up, and they can continue basically the application where you were and continue on browsing it. But this completely breaks inside of web application, inside of Ajax-style applications, because once JavaScript runs, like nobody's updating the URL. Once you click on things and you transition into different views and pages, etc., there are nothing that actually changes the UI. And so most frameworks have some way of dealing with this particular problem, but we wanted to really solve it at the core level so that you wouldn't even have to think about it. So you would get deep linking out of the box. You would have links that work like links. And I'll show you what I mean in a second over there. And you want to also support HTML5 push state, but some browsers don't have it, so you have to have a fallback, and so you have to have URL rewriting. So let me show you how that works. The way we navigate between pages is href. Now, you might not even think about that this is actually interesting until you realize what actually has to happen for this thing to work. When you have a normal, classical round-trip application, this is just how you navigate between pages. Like, there's nothing strange about this, right? But if you have a JavaScript application, this is not what you do. Instead, what you do is you register a click listener on a particular element. Whether it happens to be an anchor element is really coincidental. And when you click on it, that's when you have to execute some piece of behavior. So in our particular case, what we actually have to do is we have to say, oh, this looks like a navigation thing, and so there's actually a directive that triggers on A, and then it processes this URL, and so it can handle navigation as if you're doing round tripping, but you're actually staying all inside of the browser. Now, the side effect of that is that if you, for example, if you write an application and you use add event listener or click, and you navigate between your pages within your application using click, everything works fine. You launch your application, but users are used to hitting Alt and clicking on that link, which basically tells the browser, open this particular thing in a new tab. Except there is no link to open in a new tab, and so this particular strategy will fail. So what you end up doing is you're building in a Ajax-style application which doesn't actually behave like a real application. The bookmarking doesn't work and so on. But by following this idea that, no, we're just going to take what's already there, which is ahref. When you actually hit Alt and click on this link and opens a new tab, you're actually navigating to that URL. And so things work as expected. And so there's actually a whole bunch of code in Angular to make Ahref work the way it is was intended by the browser. Now the other nice thing that Ahref can now do, because we intercept all of these things, we can look at the URL and we can look at the two forms of it. One is using push state, one is using something called hashbang. So as we navigate between pages, we don't want to actually cause a browser to actually refetch the data or refetch the page, etc. We want to do it all inside of JavaScript. Old browsers, the only way to do that is that if you stayed on the same exact page, and the only thing you could have done is to change the anchor. This is why the hashbang comes into play. So for old browsers, the way you would navigate between pages is you're always staying on the same physical page, you're just changing the anchor. But new browsers have this idea of a push state, which actually allows you to rewrite the URL in a very nice form. We can detect this in Angular, and we can properly process this in both of these forms. And so when you're expressing yourself as /chapter, whatever, we can then detect which browser you have, and if the server is cooperating, we can then properly render the proper thing. What it means is that if you are in a browser that supports HTML5, all of your links will look without hashbang. You can take that link, email it to somebody, and if they have an old browser and server is cooperating, that will automatically get written into the new hashbang form when they can navigate within the application as expected. They can take that hashbang form, email it to you, and then in your case, Angular will notice, oh, you do have push state support, and will rewrite it back to the original form. All of this happens inside of the Ahref directive, and you don't even have to think about it. And so I just want to demonstrate a way how we took what how web was really intended to be used, and then we backported all of this Ajax magic on top of it to really make it work just the way it was intended. And an interesting side effect of this is that nobody ever notices this. People use this and everything just works, and so nobody ever notices this is actually an interesting differentiator between us and other frameworks. The last piece I want to talk about is we wanted to do a really easy server communication, and this was already kind of pointed out by Brad. We wanted to make the common case simple. There's an old quote, I don't know who said it, but he's basically, the quote that says, if you make unless you make simple things simple, then complex things are impossible, right? So if simple things take a lot of work, well, then nobody's ever going to do the complicated stuff. So you really have to make the simple stuff simple before complicated stuff becomes possible. And so we wanted to really do that with REST. So if you think about REST, most of the times, the 90% case is simply, I need to just get some data from the server and render it to the client. I don't have to do any processing. I don't have to do talking back to the server. I'm just showing it to the client. And I feel like that's the 90% case, if not, at least 90%. And so we have this thing called a resource, and a resource can return what looks like a JavaScript type, a type in the sense that you can instantiate it and so on. And we can do the second line over here, and we can say chapter.query, and that one returns what looks like a synchronous call, but it's actually, obviously it has to be async, but what it actually returns is that it knows that this is going to be an array, so it returns an empty array with a promise saying, I will eventually fulfill my promise and fill this array up, but for now I'm just giving you a reference. And the nice thing about this is that you can take that array and place it inside of the repeater, and oops, it should have said ngRepeat, not ngBind. And if you place it inside of the repeater, then you can very quickly, you can have the ngRepeater simply look at the array and say, well, that array is empty, there's nothing for me to do. And eventually the server responds with the data, the array gets populated, the ngRepeater kicks in and unrolls itself and fills up individual rows inside of the column. So this is a case where we've taken all of the pieces that we talked about until now, which is the model, the updates to things, the way the repeat works, asynchronization of it, and just kind of put it together and produce something that's very simple and clean. So literally, with a single line of JavaScript for fetching the data, you can go directly into your template and just express your intent of what you wanted to do. I don't know of any other framework that can really express this powerfully simple ideas. And why this is important is because at least 80-90% of the code is really just fetching data and showing it to the user, it's not cluttering it. And so you can then go on and focus on the interesting use cases of the application. And then we're going to get to new stuff after a break. So now is your time to ask questions. Yes. Mm-hmm. Yes. So the question was, if I have a repeater, such as here with chapters, the repeater unrolls and makes multiple copies of the row, and in this case, there's a chapter.name. What if somebody's actually changing the chapter.name? Will it correctly update in this particular case? And the answer is yes. It does correctly update that. Back there?
You talked about the server cooperation for URL rewriting.
Correct.
Does that mean that the server has to detect just a browser string to know if it supports HTML5 and send a redirect request, or what do this?
Okay, how does server cooperate?
Yeah.
So you were talking about this particular case where we can have server.com/chapter1234, or we can have server.com/hashbang chapter1234. And so why do servers have to cooperate in this case? It turns out that when you make a request to a URL that contains a hash, everything after the hash actually does not go to the server. So the server only sees a request to server.com/. And in this particular case, the server.com has an index.html, and so it always serves index.html at that particular location, because wherever you are inside of the application, you're always hitting the same exact URL. In the case where we're not using hashbang, the path which the server gets hit depends on where you happen to be inside of the application. But in all cases, the server has to always return the same index.html to bootstrap the application. And so what it requires, when I say cooperation from the server, is that it requires the server to do two things. First, the server has to say, no matter what path I get, I always serve the same index.html, right? Because there's no actual directory called chapter/1234 on a server. That doesn't exist. It's bogus. So there's a simple just redirection that says everything after this particular path gets ignored, and I always serve up the same exact index.html. That's the first part that the server has to do. The second part of the server has to do is it has to allow redirection, which is that if you come to chapter/123 and the client says, yeah, but I don't understand push state, then the server actually has to say, oh, okay, let me do a redirect back to the hashbang. And maybe I got this wrong. Does this, Brian, do you know if the client can do the redirect, or is it the server that does that? Oh, the client does it. Okay, so there's not two requirements. There's only one requirement. The only requirement is that the server treats everything after the path basically gets ignored, and the server always serves up the same index.html. That's the only requirement from the server. Good question. Yes. So the question was, eval has security problems. We implement essentially our own eval, and how do we prevent those same security problems from occurring? Very fair. So let's talk about why eval has security problems. The issue is that because you could put any kind of code inside of the eval, it's relatively easy for, if let's say there was a user code, to get hold of the window object. And once you get hold of the window object, you can essentially do anything you want inside of the browser, because you have access to all the APIs, you can invoke anything you want, and so on. And so the real trick comes in, we want to just make sure you can't get hold of the window object. Now there is a lot of different ways, a lot of different clever ways that are non-obvious in which you can get hold of the window object. And so what we do inside our own Lexer parser is we check for that. And we prevent you from being able to get hold of the window object. Once you can't get hold of the window object, you can't get a hold of the function, you won't be able to, for example, call alert or any of those things. So that's really how we get around this particular problem. This has already gone through Google's security review. We like to think that we have some pretty good folks on our security team, so we feel pretty confident about this particular thing. But if any security experts are in the crowd, feel free to look at it and help us make it even more secure. Correct? So you're always okay. So the question is, how does dirty check work? And there's a concern that you're stating, which is, what if there is circular dependencies inside of your data structures? That's not an issue because we're not comparing. When we're comparing things, we really are comparing the references. So we're saying if a.b.c is a path that we care about, we evaluate a.b.c and we get back some kind of either an object or primitive, and we're comparing its identity to the previous one. And so, if a.b and c all point to the same object, which is back to itself, we don't care because we see it as a path we have traversed. We returned a particular value, and we're simply comparing the identity of the object. So even if you have cyclical things, it really doesn't cause any trouble at all. Yes? How does a compiler know that it's dealing with a custom directive? Well, there's no other directives but custom ones. I'm not sure I... So how does it differentiate between the directives we've written and its plain attributes? So the browser takes care of the plain attributes, right? The only way to render anything is to use the browser. So what the directives do is they eventually produce browser side effects. Rather, at the end of the day, somehow we have to get the DOM to be changed in this particular way. So the compiler doesn't actually have to differentiate this because all the compiler has is a list of all the possible directives to look for. And as it's going through the list, it's just matching them up. And if it comes across something that's in the list, then that means that particular function has to be executed. That function will either directly or indirectly cause a change in the DOM, and it's the change in the DOM that will be eventually picked up by the browser itself. So the browser ignores all of the directives we place on a system. So all this extra ng dash something, all this is nonsense to the browser. The browser has no idea what to do with it. But the compiler allows us to execute a piece of JavaScript which will have a side effect that will actually cause the actual change which we want, which is changing the class or adding attribute or setting the text or something like that. Yes? So the question is, does dependency injection reuse instances? And the answer right now is yes. Currently we have what we call a cache inside of the injector. And every time, once we create an object, we cache it, and all the future requests for the same identity of the object returns the same thing. Which means that within a system, all the objects are essentially singletons. You only have one copy of a HTTP service, one copy of a compiler, one copy of, and so on and so forth. There are plans to change this for the future, but this is just how it works right now. And should we take a 10-minute break? Okay, let's take another 10-minute break. We'll see you here in 10 minutes, and we'll talk about what's new in one